Hello everyone. Today I am going to discuss a method, rather a direct method to solve system of linear equations, that is the matrix inversion method. Now I hope you all have learned the matrix inversion in class 11 and 12 CBSE or ISC syllabus, but again I will repeat today and I will show how to solve system of linear equations using the matrix inversion method. Now the very basic formula to find the inverse of a matrix is x equals to A inverse B. This will be the working formula for our solving system of linear equations. Now, how to find the inverse of a matrix? First of all, if a matrix is given, then we need to find the determinant of that matrix. So, if a matrix is given, then first of all we need to find its determinant, and then we need to find its adjoint. Now what is adjoint? Adjoint is nothing but transpose of the matrix containing the cofactors of the parent matrix. So adjoint is nothing but the transpose of the matrix containing the cofactors of the parent matrix. Now after finding the determinant and the adjoint of the matrix, we need to see, or rather inspect, whether the determinant is equal to 0. If the determinant is equal to 0, then the matrix will be known as singular matrix, and in that case we can't find the inverse of that matrix. So for finding the inverse of a matrix, the matrix need to be non-singular, that is not equal to 0. Now if the determinant is not equal to 0, then what we will do? We will use this formula A inverse equals to 1 by determinant into adjoint of A. So this is the formula to find the inverse of a matrix. A inverse equals to 1 by determinant into adjoint of A. Now if the adjoint matrix is not divisible by determinant, then our inverse will remain in this form only, that is 1 by the determinant value into the adjoint matrix. So keeping this formula in mind, let us solve an example to make the concept clear. Now our example is, there are three equations given: x plus y plus z equals to 4, 2x minus y plus 3z equals to 1, and 3x plus 2y minus z equals to 1. What we need to do is to solve this system of linear equations using the matrix inversion method. Now before proceeding with the problem, let us see what we need to do. Now first of all, we have to keep in mind that x equals to A inverse B. This one we need to keep in mind. Now we will define x, A and B in few minutes. Now first of all, A. What is A? A is nothing but a matrix containing the coefficients of the variables. So 1, 2, 3, this makes the coefficients of x. 1 minus 1, 2. This makes the coefficient of y. 1, 3 and minus 1. This makes the coefficients of z. So this forms A. Now B. What is B? B is nothing but the constant terms in a matrix form. 4, 1, 1. Last but not the least, X. X is nothing but the variables themselves. That is X, Y and Z. So in order to solve the system of linear equations, we need to find the value of this matrix called X. So we will find out this X matrix using this formula, and we will find this A inverse using this formula. So we need to just imply two formulas in order to solve the system of linear equations. Now first of all, we will find out the inverse of A. So for that, we need to determine the determinant of the matrix. So the determinant of A will be 1 into minus 1 into minus 1 minus 3 into 2 minus 1 into 2 into minus 1 minus 3 into 3. So 2 into minus 1 minus 3 into 3. And last 1 into 2 into 2 minus 1 into 3. So this is equal to 13. Now see, 13 is not equals to 0. Therefore A is not singular. That means we can find out the inverse of A. So next step will be finding out the adjoint of A. So for adjoint of A, first of all let me erase this one. So determinant of A is 13. Now we need to find the adjoint of A. So the adjoint of A will be the matrix containing the cofactors. So the cofactor of 1 is minus 1, 3, 2. Cofactor of again 1 is 2, 3, 3 minus 1. Cofactor of 1 is 2, 2 minus 1, 3. Similarly, cofactor of 2 is 1, 2, 1 minus 1. Cofactor of minus 1 is 1, 3, 1 minus 1. Cofactor of 3 is 1, 3, 1, 2. Cofactor of 3 again is 1 minus 1, 1, 3. 1, 2, 1, 3. And cofactor of minus 1 again is 1, 2, 1 minus 1. Now transpose of this matrix will be our adjoint. So this will come out on simplification as minus 5, 11, 7, 1 minus 4, 3, 4 minus 1 and minus 3. So this is the adjoint of A. Now what we have to do? Now we need to find the value of inverse of A. Now to find out the inverse of A, we need to divide the adjoint by the determinant value. So now let us find the inverse of A. So A inverse is equal to 1 by determinant of A into adjoint of A. That means 1 by 13 into minus 5, 11, 7, 3 minus 4, 1. 4 minus 1 minus 3. So this is the inverse of A. Now to solve the system of linear equations, we need to find out the value of x, and that is equal to A inverse B. That means 1 by 13 minus 5, 11, 7, 3 minus 4, 1, 4 minus 1 minus 3 multiplied by 4, 1, 1. So we will multiply these two matrices and then we will divide the resultant by 13. So the multiplication of these two matrices will give us 1 by 13 into minus 13, 39, 26. So we will divide this matrix by 13 and hence our final answer will be minus 1, 3, 2. So this is our x. That means x, y and z. So we can finally write our x is equal to minus 1, our y is equals to 3 and our z is equals to 2. So this is our final answer to the question, that is solve the linear system of linear equations using matrix inversion method. So this was the matrix inversion method to solve the system of linear equations. In my next video I will be dealing with the LU factorization methods. Till then, thank you.